We're coming down the home stretch on our unit on solving equations. Today we're going to talk about solving equations with special solutions. But first, let's start out with these two bell work problems that we would do at the beginning of class to get kind of warmed up. As I notice, I've got a set of parentheses somewhere in each of these equations. So my first step is going to be to get rid of the parentheses by using the distributive property. And once I do that, my second equation in each case looks like these. The next step beyond that then is going to be rearranging the equations so that I have all of the variable terms on one side and all the constants on the other. And I keep in mind that every time I have to cross the equal sign with one of my terms to rearrange it, I change its sign to its opposite sign. And now I go to the next step, and that is to collect together those like terms on each side. And then I'm down to one last step, and that is to divide by the coefficient of the variable. And so when I do that, I end up with my final solutions. For number 1, x equals -4, and for number 2, a equals 8. So hopefully we're getting a good grasp on how to do these kinds of problems. Now, as we begin today's lesson, I want to ask you these questions. Does every equation have a solution? Does every equation have just one solution? Is it possible for an equation to have two or more solutions? And we'll answer those questions as we move forward today. So, what we're talking about again is equations with special solutions. If you are watching this at home, click on this little link to YouTube, and there's a really great video on how to look this up. Okay, so special cases. So we've noticed so far that when we've solved an equation for a variable, if we end up with just x equals 1 or x equals some number, then that would be considered a case when you have one solution. Now, if we're solving an equation and all of a sudden we notice that the variables disappear, and I'm left with one number that doesn't equal another number on either side of this equal sign, then I know that this equation this problem has no solution. Or if I'm solving the equation and the variables disappear, but I'm left with the same number on each side, or x equals 0, or 0 equals 0, then I know I have an infinite number of solutions to this particular equation. So let's try a couple of examples, and so you can see how this works in action. So this first problem looks very familiar, like one we're used to seeing. So I'm going to subtract 2 from both sides to get x by itself. And when I do that, I end up with x equals 5. So this only has one solution, and that solution is 5. So pretty straightforward with that one. Now how about this one? This one's got variables on both sides, so if I move this x to the other side and this 2 over here to the right side, then we'll be ready to solve this. So I will have x subtract x on the left side equals 7 subtract 2 on the right side. And when I do x minus x, I get 0. 0 equals 5 is my final answer. So in that case, I have two numbers that don't equal each other. So what we say in this case is that there is no solution. There's no value of x that would make this equation true or make it work. Okay, so first example of a special solution. Okay, how about this one? If I notice, kind of interesting, they look like the same thing on each side. So if I start subtracting variables from both sides or moving them to both sides of the same side of the equal sign, I notice that the variables disappear. I subtract 2 from each side, they disappear, so I'm left with 0 equals 0. And this was the case where there's an infinite number of solutions, which in this case stands for all real numbers. So no matter what real number you put on either side of this, the x's are the same, and you're going to add it to 2, so both sides will always be the same no matter what number you put in. So all real numbers is what you would write down for your answer. So all real numbers in this case. So we've seen one of each kind now. Let's keep our trend going here. Okay, so let's do the rearranging part here. So we're going to have negative x plus 4x on this side equals negative 7 minus 2 on this side, and negative 1x plus 4x is 3x, and then we have negative 7 minus 2, that's negative 9. So if I divide by 3, lo and behold, what do I get? Well, I get x equals negative 3. So that's got one solution, and it's negative 3. All right, here's another problem. Let's use the distributive property to get rid of our parentheses. So 3 times 4, 12x. 3 times negative 1 is negative 3. And I have 12x on this side as well. Subtract 3. So I notice if I have the same thing on both sides, if I start subtracting and moving things around, pretty soon I'm going to notice that I have 0 equals 0. Because 12x minus 12x on both sides is 0. And negative 3 plus 3 and negative 3 plus 3 is 0 on each side. So this is one of those examples of true for all numbers, okay? All real numbers. All right, so that's how you tell. If you got the same thing on each side, basically. No matter what you put in for x, you'll still get the same answer on each side. All right, let's try this one. So we got 8 times x. You get 8x. 8 times minus 5 is minus 40. And then we end up with negative 34 plus 9x. Now I'm noticing right away that the numbers are different and the variables are different. So this is probably a pretty good indication I'm going to get one solution. So 8x, bring the 9x over, make it minus 9x, equals negative 34 plus 40. And then 8x minus 9x is negative 1x. And negative 34 plus 40 is 6. So we divide both sides by negative 1. And we end up with x equals negative 6. So that's how you do a problem like that. So that had one solution, didn't it? Okay, let's look at this next one. So when I multiply this 4 by that 4 and that 8 to get rid of the parentheses, I get 16x plus 32. And right away I notice that on the other side I have 16x plus 32 as well. So if they're the same on both sides, if I were to subtract everything off on both sides to try and isolate the variable, I'd end up with 0 equals 0. So this is another one for all real numbers, right? All real numbers. That's how that works. Now, if you're a little, wondering, I'll go ahead and demonstrate. Minus 16x, minus 16x, and also I've got a minus 32 from both sides, and minus 32 from both sides to try and get one side or the other solved. And I notice that in both cases, that cancels, that cancels, that cancels, that cancels, leaving me with 0 equals 0. All right, so let's kind of summarize. And when solving multi-step equations, we get one solution if we end up with a variable equals one number. We get no solution if we end up with one number that does not equal another number. And we get infinitely many solutions if we end up with 0 equals 0. So here's your assignment.
Could you please move it so we can jumpstart? Oh, we need you in the office.